Chapter 10 takes the concepts from Chapter 9 forward to multiple populations. In Chapter 9, we looked at just one single population, either it is regular population or a population of proportions, and we did hypothesis testing and confidence interval and so on. In Chapter 10, we take that to two populations, okay, and by the end of Chapter 10, we're going to take that 2 into even more than 2, 3 or more populations. And what are the different tests that we can do if there are confidence intervals possible? How do we do confidence intervals? So these are the topics covered in Chapter 10. So when it comes to two samples, we will look at both population of X-bars and population of proportions. So we start with these three files that are available. Make sure that you download them. Use the PowerPoint file to follow along these lectures, and then the formulas.pdf file, you can print that and keep it by your side so you can refer back to those formulas. And the shell file, download the shell file and complete the problems in the shell file as directed in these tutorials. So the objectives here, as I said, we look at two populations of means and proportions and variance. So there are three things: mean, two population means, two population proportions, two population variances. But when it comes to two population means, there are two different scenarios we're going to look at. One where the samples are completely independent, and a second scenario where the samples are not independent, kind of related. So there are two versions of two population means, one version of population proportion, and then one version of population variance. So those are the two population cases. And then finally we'll end the chapter with multiple populations, more than two. So for the two population cases, and we're going to do two sample tests. So here are the four scenarios. Two population means independent samples, and then two population means related samples, then two population proportions and two population variances. So these are the two population tests that we will be dealing with. And of course there is the multiple populations, 3 or more, and that analysis is called ANOVA, and we'll come to ANOVA after we get done with these four scenarios. So population means with independent random sample. So the tests are going to be concerning the difference in the two population means, mu sub 1 minus mu sub 2, and we can set up the hypothesis like before, and we'll get to that in just a second. And we'll compute from the two samples x bar sub 1 minus x bar sub 2 as a point estimate for that unknown difference in the population means. Then sigma sub 1 and sigma sub 2, we're going to consider only the case where these population standard deviations are unknown, which is the most normal case. So we're not going to look at a case where the sigmas are known, which are very rare and not common at all. So in the case when the two population variances are unknown or standard deviations are unknown, we're going to look at two different cases. One is it reasonable to think of the standard deviations being equal? And in many situations that could be true, because we are not looking at two population means that are entirely, completely unrelated. They're kind of related concept. The response variable, the underlying response variable will be the same. For example, you want to test whether the average hourly wages for male workers and female workers are same or are they different. So here the underlying population standard, the standard deviation, the variability of wages among men and the variability in wages among women workers, it is reasonable to think that standard deviation would be about the same. There is no reason to think that they would be different, because if they are same, then the computations become kind of relatively simple, or so there is a advantage to assuming that the two standard deviations are equal, and we will be looking at a test for that, but it is reasonable in that case. But if you think that it is unreasonable, okay, to assume that the two underlying sample standard deviations are equal, Then we will have the second case, an unequal, unknown and unequal. So how do you deal with that? So we'll have two different tests that we're going to be looking at for this case of independent random samples from two populations. Okay. And the test that we're going to look at, pooled variance t-test, we're going to pool the two variances that are unknown, but we have assumed that they will be equal. So we have pooled variance, and then using the pooled variance we will come up with a t-test, and these are the three different variations of the hypothesis, exactly like what we saw in chapter 9. The two-tailed test, which is right here, and then the one-tailed test, the left side alternative less than 0 and the right side alternative greater than 0. In each of these three different cases, our hypothesis test critical area would be like this. In the case of less than or equal, less than alternative, the rejection region is on the left. For greater than 0, the rejection is on the right. And in the case of two-tailed test, it will be alpha over 2 equally divided into the two tails. So here let's look at what are the assumptions, underlying assumptions for this t-test when the sigmas are unknown but assumed equal. So samples are randomly taken, the populations are normally distributed, so which means that the sample sizes must be greater than or equal to 30, in which case the central limit theorem will kick in, and it doesn't matter what the population probability distributions are. You can assume the x bars will be normally distributed if the sample sizes are large, that is at least 30. But if it is less than 30, then you have to assume that the population itself or the two populations themselves are normally distributed. And of course, in this case, we are assuming the two population variances, which are unknown, but they are assumed to be equal. So here is a formula for the pooled variance, how to pool the two sample variances from the two samples, and then use the pooled variance in your t-stat. And the degrees of freedom is n sub 1 plus n sub 2 minus 2. And then we use the t-table or we use the p-value to conclude the test. And we can also develop confidence interval by going x bar sub 1 minus x bar sub 2 and then t-table value times the pooled variance estimator based standard error. So this will be our margin of error, and then we'll have the lower and the upper confidence interval limits. So here is a numerical example worked out in your PowerPoint file. Okay, when the sample sizes are given, sample means and sample standard deviations, and then you work out, plug in the values into the sample and work it out. So let's take an example from your textbook and then work it out in Excel.